Well, here we have another calculus problem for you to have fun with. This one becomes more of how much algebra do you know than how much calculus. So we're going to ask, can you find the derivative when y of x is not isolated? In particular, the problem is find the derivative of y of x cubed plus 3y of x squared plus 3y of x plus 1 equal to e to the 3x. You might think implicit differentiation. Well, that could be the way to go, but there are problems. Uh, the expression that we get out for y is going to be kind of awkward. After differentiating, we could factor out the dy of x dx, and we're left with 3y of x squared plus 6y of x and plus 3. So there's a little bit of a strange look there. We could handle it, but it's not what we really want to do. This leaves us with an awkward expression of y to the x. I like to have a more simple answer than something like that. So now use your algebra. You first notice the pattern on the left side of the equation. Y of x cubed plus 3y of x squared plus 3y of x plus 1. It sure looks like a binomial expansion here of y to the x plus 1 cubed. Notice the coefficients, 1, 3, 3, 1. That should be a familiar pattern if you're well skilled in algebra. So we do have, in fact, a binomial expansion. So in calculus, the more algebra you know, the better off you are. In fact, the calculus techniques are not that difficult. The problem with calculus is the algebra and also the trig all would tend to make it more complicated. You never know what you're going to want to use. So we take the expression y of x cubed plus 3y of x squared plus 3y of x plus 1, and we're going to let that be y of x plus 1 cubed. And that's equal to e to the 3x. Now, so looking here at the back end, we see that if we take the cube root of each side, in other words, raise what we see to the 1/3 power and cancel the powers, what we're going to end up with is y of x plus 1 equals e to the x. Now all we have to do is subtract 1 from each side, and we got an expression for y of x. Y of x equals e to the x minus 1. Okay, now taking the derivative is easy. If I take dy dx, I have to take the derivative of e to the x, which is e to the x. That's the function, that's its own derivative. And then a derivative of a constant is 0. So I get this nice simple solution. The derivative of y of x dx equals e to the x. Oh, we did not need implicit differentiation. A very straightforward derivative here is all we needed once we saw the algebra. So algebra should be considered when wishing to make a messy situation simple. And this was a messy situation, and it sure got simple. Well, I have more videos and still more coming. Hope you enjoy practicing your problems and seeing how much you happen to real laws when looking at them. The more you do, the better you get. And so please consider subscribing, and that will make them easier.